Wonderful. Let's start. First of all, Happy New Year. Thank you very much for joining us in this first Into the Block webinar of 2021. We had a spectacular year last year with over 100 customers and working some very ambitious projects. And we're gonna be sharing some of that in the next with you in the next few weeks. Today, I'm particularly excited because we're gonna talk about some of the recent work that we have been doing in predictive models for crypto assets. We have done a couple of webinars about this, and this one is about new ideas, new things that we have discovered, new things um, that we're trying. And so we're very, very excited about this webinar. The agenda is super simple. We're going to talk about some of the challenges about predictive models for crypto assets, new trends in research and practical implementations that we're using, some technologies that we're adopting and that we think are very relevant if you're working in this space. And I want to dedicate a couple of slides to talk about the DeFi angle for for predictive models in crypto assets. As usual, a couple of logistic notes. You can use a Q&A panel at any point. If you have any questions, I'll stop a couple of times during the presentation to take questions, and obviously at the end. So as we always do, we want to give you a 1-minute update about recent events into the blog. New customers continue to go live. Just a few days ago, SushiSwap went live, as well as a couple of customers like ChainX in Africa and Binetco. And we're going to be announcing more and more deployments of into the blog analytics in the next few weeks. So a lot of customers continue adopting the ITV platform and going live. We also announced, very related to today's topic, we announced prediction models for the Dash cryptocurrency. Dash is a customer of Into the Block and a very good partner. And we timed it perfectly. We launched the models. The price went up about 37%. Somehow the models managed to hold up during the rally, but we have been retraining it constantly because it's been a very tumultuous market momentum. And a very exciting update. Sorry about the empty mock-up, but in a few days we're gonna be doing what we think is a major release. Over 70 analytics that compare crypto, particularly Bitcoin and Ethereum, against traditional market vehicles. So you're gonna have comparisons against equities, fan stock, Tesla, crypto-related equities like PayPal, like MicroStrategy, like Square, ETF, not EFTs, ETF for emerging markets, for technology, for banking, market indices like Russell 2000, Nikkei 225, the FTSE, commodities like precious metals, gold, silver, oil. So a lot of market vehicles. So given that Bitcoin and Ethereum are seeing more adoption from institutional investors and traditional market investors, we want to provide a single place in which you can compare different investment theses and see which vehicles how are they comparing and contrasting against taking positions on Bitcoin. So go sign up for Into the Blog. It should be very exciting. Some of our partners like CoinMarketCap are already using some of this, so it should be a very good release, and it's only days away. So that's the update about Into the Blog. I have a lot of ground to cover. This session is very technical, so it's very oriented to machine learning. What we're going to do is to discuss a lot of the new ideas, a lot of the new things that we have been seeing in the strategies and the predictive models that we have been building for crypto assets. So a lot of quant desks, a lot of people that work in the space, they tend to be super secretive about this stuff. We sort of try to take the opposite approach of share a lot, because we think this is complex enough that it's not that easy to replicate. We welcome a lot of, we're testing a lot of cutting edge ideas that a lot of feedback will be welcome. So for the ones of you that don't know, Into the Block is very well known as an analytics platform that is distributed in many across many exchanges and data providers in the crypto space. But Into the Block also has a second division that obviously, for obvious reasons, we don't publicize a lot, that is called Quant Services, in which we work with the top quant desk in the crypto space and in traditional capital markets, formulating quant strategies for both CeFi and DeFi. And a lot of what you're going to see here is the result of that work. So it's all practical experience, nothing made up. It's not research. It's not theoretical ideas. Are the result of a lot of experiments and a lot of failure, if I can say that. So let's start with a very, very simple question. We're seeing constant breakthroughs in deep learning and artificial intelligence across all sorts of areas: computing vision, natural language processing, self-driving vehicles. You're seeing what GPT-3 is doing. You're seeing what AlphaFold is doing, all those things. So why not in capital markets, right? Like, we haven't seen a major breakthrough in when it comes to stock or equities markets in a very, very long time. So the problem there is that capital markets as an environment for artificial intelligence is fundamentally different than the environments that we use in all these deep learning techniques. So it's very different to train a model to identify cats in images than to predict the price of an equity or a crypto asset. So there are many, many challenges. So obviously, markets, what we call the stability challenges, and markets are dynamic and are constantly changing. The past is not a reflection of the future in capital markets, not directly. Certainly in some more stable vehicles like fixed income and things like that, it works. But in equities, in crypto, the past is really not a strong reflection of the future. So you have this challenge of you train a model to do something based on past experience. Well, what you might encounter situations like what we're seeing now in crypto that we've never seen before. So Bitcoin has never been at 30K. So how do you react to things like that? Then the irrationality factor, sorry, the problems of working from home, the irrationality factor in which markets are constantly vulnerable to human behavior, right, to irrational behavior, and that translate into market trends that are not exactly predictable. So time series is a very classic scenario in machine learning, but for markets, it's one of the hardest problems to solve. Crypto in particular brings a whole new dimension in terms of challenges to this space. So when you think about the benefits, about the uniqueness of crypto to work on, to apply predictive models, obviously might be the richest asset class in terms of data that we ever seen. We have footprints in public ledgers like blockchain, and we have all sorts of different, very unique data points. We can inspect protocols in detail and things like that. But in terms of the challenges, there are many. The data sets are very small. So we only have 12 years of history. So you can train a model for, when you compare that, you can train a model in a bunch of years of history of the S&P 500 compared to what you can do in crypto is very, very small. The data is really poor quality, and you have all sorts of gaps, exchanges going down, you have spoofing, wash trading, all sorts of bad behavior that contaminates the data set. Then there are outlier events of what we're living now in crypto that happen all the time. I don't know how much they can be called outliers if they happen all the time. Markets going up, markets going down, swings that we haven't seen before that make it really hard to predict. And obviously things like changes in protocols, forks, market manipulations, things like that. So it creates a very unique playground, but also brings a very unique set of challenges that we never seen. When I explain this to my ex-colleagues in quant circles, it's a lot of the techniques that they're applying they don't in traditional capital market vehicles, they don't really extrapolate to crypto. So let me show you a few examples to put it in perspective, something that the last 2 weeks, right, something very tangible. How in the world do you train a predictive model for something like this, right? In just a few days, right? Suppose that you train a predictive model that we have on forecasting Bitcoin prices every 5, 10, 60 minutes, and something like this happens, right? You see a massive spike from 35,000 to almost 38,000 in a few hours, followed by a little bit of a rally, but then there's this massive drop, right? So what do? So if obviously any predictive model will be fooled by this and the performance will be affected, ours was. But then you have this challenge of what do? If you retrain the model to capture this knowledge, then you're likely walking into what is called overfitting territory, because this just happened. So you're injecting knowledge that is very recent about a very recent market event. So you have nothing to test it against. But then if you don't retrain the model and this pattern continues, then your performance might continue what is called experiencing model decay, right? It will continue degrading. So it's one of those challenges that is really hard to replicate. And then how about something like this, right? Suppose that you have models that are hooked to APIs, to order book APIs, fees like Coinbase, and they're failing because of the increase in volume. This might seem like a silly stuff. It doesn't happen in capital markets. You never hear about NASDAQ going down and things like that. So many of the infrastructure that we build in traditional capital markets assume stability from the data providers. And in crypto, because it's very nascent, this is not Coinbase's fault or anything. It happens, right? Because it's very nascent. You have all these challenges. But imagine that you have a model like we do that is receiving data from order books, right? And then for 2 hours, there is no data point. So what do? The model might get confused, or for 2 minutes that there are no data points. It might output a ridiculous prediction, because it might think that something wrong is happening with the market. So despite those challenges, crypto is obviously a phenomenal playground for predictive models, and the challenges are partially what makes it so fascinating. So if within the spectrum of artificial intelligence and deep learning, this type of predictive models fall under the umbrella of what is called time series forecasting, and there is an entire theory about this type of problems. But to understand how would you classify crypto predictions in that spectrum, there are a few characteristics that you should know. So for instance, crypto predictions is what is called multivariable time series forecasting problem, in which you're not predicting price or volatility with one thing, right? But with many variables that are interrelated and that have very non-linear complex relationships. It's also multi-steps. You're trying to predict multiple steps in the future. It could be 5 minutes, 7 minutes, 60 minutes. It's not an end of the year forecast sales that has a single step. It's also multi-series. This is one of the ones that is harder to understand. But when you think a time series of order books or futures or blockchain transactions, it's not one time series. It's many embedded, like some that are time series in 5 minutes, in 10 minutes, with certain characteristics. So what these models, what the more sophisticated models do underneath, is to try to predict those individual time series at the same time. And also it's very seasonal. So you have, like right now, it's a bull market. So you have trends that are very specific to this type of environment. You have trends that are very specific to bear markets and things like that. So those are characteristics that when you're trying to frame a problem for crypto predictions, you should consider. Now, from the historical perspective, from the type of techniques that are available out there, when you think about the complexity of the type of prediction that you're trying to make and the interpretability, you would like to understand, right? What the model, when the model tells you Bitcoin is going to go up in the next hour, why it's telling you that? So you can think about 3 types of time series forecasting models. Obviously, traditional statistical methods that are well documented. There is a school of machine learning, the methods that were applied to this, like classification and things like that. And the new school of deep learning, that is where the newest body of research is. So the more complex environment, deep learning is outperforming most of the other models, but it's also, they're so complex that they're very hard to understand. So these are slides that I used before, so I'm gonna go very quickly through this. In our experiment, so we have tested all this type of models. Time series forecasting models, so things like ARIMA, they're super easy to implement, but they're super vulnerable to Bitcoin market fluctuations, and they're not very optimized for things like seasonality and things like that. Traditional the new school of deep learning models, they're very expensive to implement. They're difficult. They're really hard to interpret, but they're showing the best performance. They're very well equipped to tackle the challenges of Bitcoin prediction. So the type of sophisticated thesis that you can orchestrate in this type of environment with deep learning, it seems to be like a better suited method for this type of approach, and this is where we're spending the bulk of our time, and not us. I mean, if you look at the everybody that is doing high scale time series predictions, like Amazon or Google and all that, this is the area they're spending a lot of time. If you look at all the top quant desks in the market, D, Shaw, 2 Sigma, DRW, they're all building teams to try to focus on deep learning. Everybody thinks it's a future, you know, but it's obviously very, very new. When it comes to crypto, the way we think about the world is we believe that predictive models are gonna be like 80% deep learning techniques with some statistical and machine learning on top of it to refine. Like, we don't think one school solves everything. Like, we think many problems are you can take an initial approach with a deep learning technique, but then have a statistical methods that reframe that strategy. To give you a very good example of this, some of our predictive models, I suppose, output a prediction for the next hour. Then we complement it with some statistics on top that actually tell you whether that prediction is actionable, whether you can actually buy or sell or things like that, based on a more statistical criteria that is not directly related to the prediction. So we have been working on this for a few months. We have clients are using a lot of the work we do. We're trading on this stuff. Obviously we're exploring all sorts of new ideas, and what I wanted to do in the next few minutes is to share a lot of the new ideas that we're excited about that we have tried. And again, this gets into the weeds of of the technicalities of how you architect this type of models, but hopefully you will find the content relevant. We think it's very, very cutting edge. So two fundamental challenges that we're trying to solve that we think any organization, any team working on this should focus on. One is accelerate experimentation. So when it comes to creating alpha generating models for crypto, for any other asset class, rapid experimentation beat the best models all the time. So it's more important that you test new ideas and move very quickly than that you've uncovered like a magical idea, because that idea is going to stop working at some point, particularly in a very inefficient market like crypto, in which you have market momentum swings that can kill any predictive model. Then the idea of recovering from that becomes more and more prominent. Then this idea of incorporating new research methods, and I'm not talking about papers and things like that. Let's take the level of methods that have been tested, that have been implemented, that you can find libraries for them, but they're still very computational expensive, hard to understand. They don't have mainstream adoption, but we think that in that cutting edge is when you're going to uncover a lot of alpha. So for us, it has been very important to take what Amazon is doing, what Uber is doing, and try to retrofit it into what we're trying to do. Let me go even deeper, right? Like, how are we actually doing this type of thing? So the traditional approach to experimenting, to producing crypto predictive models is you start with a data set, you generate these things that are called features, or so you can think about it as your predictors. Then your data science team will say, oh, we want to try this model or this other model. You try that, you evaluate the model. Most of them are going to fail. That's a business, right? You fail on 90% of what you do. And then you try again, regenerate features, build new models and things like that until you find something, and then you implement a trading strategy on top of it. This is very sequential, right? You go one model after another and test. And this is what most teams do. what we're thinking about, some of the newest ideas that we've seen in this space, is we would like to move from thesis like this, like we would like to forecast 10 basis points on the price of Bitcoin in the next hour using exchange flow data sets or order books, because somebody believes that data set contains alpha. Like we have had this example, clients coming to us and said, this data set that you guys have is super high alpha. They cannot tell us why. It's all completely subjective. Right? And then you try models and ideas and fail, and try something else and fail, and try something else until you uncover something or not, and it's very frustrating. What we would like to do is to move to a world in which we can say, we would like to forecast 10 basis points on the price of Bitcoin in the next hour. Done. How? Whether it's using order books, blockchain record, derivative, it's using everything, right, at the same time. What is relevant for that thesis will show predictive power. What is not won't be used, right? But that will allow us to experiment very quickly, and we have been playing with a lot of these ideas. So even more specifically than this, is there are two trends that we're super excited about and we have been adopting. One is this thing called representation learning, and now it's this new world of automated machine learning and neural architecture search. So representation learning is a way, so think about this scenario as, is there any quants or people working on this in the audience? This is going to sound very familiar. So somebody like a domain expert, one of our clients comes to us and say, look, I believe we have, this is a real example, right? We have a data set that uses machine learning to classify crypto exchanges at the blockchain level. And we can tell you how much money is going in and out of Binance, how much money is going in and out of Coinbase, right? So somebody actually believes that that data set has high alpha. It's intuitive, right? If you can see how much Bitcoin is flowing into Coinbase, there should be some predictive power there. So then our data science team tests 1 million ideas against that data set, and then none of them actually work, or just a few of them produce some results, right? And at that point, when we're testing those ideas, or experts will say, look, we think the average volume is relevant. We think the total amount that is transferred is relevant. We think the exponential moving average should have predictive power, because those are statistical constructs that seem to make sense. Now, a more interesting idea here is using this thing called representation learning. That is, you give it a data set and it learns everything it can from it. So instead of somebody coming to us and saying these 5 features should have predictive power, we say, look at this data set and calculate everything, 300,000 features. The average flows in the last 30 minutes, 60 minutes, 5 minutes, 20 seconds, the first order derivative, the second order derivative, like a million things like that, and then complement it with the handcrafted features, and let's see what predicts. And what this gives us is the idea of generating a massive amount of features immediately, right, that we otherwise wouldn't have thought of, complementing with the features that our experts generate, and have a massive data set that you can test again. So this is one idea that we think accelerates a lot. And then this second idea of automated machine learning, that is this concept, very new, of using machine learning to generate machine learning. So in the case of crypto asset prediction, it goes like this. You have a problem, same problem. We want to predict 10 basis points of the price of Bitcoin in the next hour. And a data scientist will say, we want to tackle that with convolutional neural networks, with random forests, with this thing, right? Because that's an architecture that they like. That's a model that they feel that could be the right for the problem. But you don't really know if that's the right model for the problem, right? There's some things everybody know, convolutional neural networks are better for images, LSTMs are better for time series, but you don't know what really works. So instead, with AutoML, you can test hundreds of ideas at the same time. So what we're doing is we're taking a data set that is very curated, and we're taking an AutoML stack and say, look, test 500 models at the same time. Those models some of them will work, would output something that says, look, this architecture is showing promise. And then we take that and we attack that problem, that architecture, we try to improve it with more sophisticated techniques. And that fast track the way that you can do experimentation, because you're testing 500 ideas at the same time. And what is very good is at discarding what doesn't work. It probably is not going to show you what works. It's going to give you an idea what could work, but it's really good at saying this doesn't work, this doesn't work, this doesn't work, and you're not wasting time testing ideas sequentially. Again, this is very, very new. The stacks are very mature, but there is a lot of promise here. So when you put all that together, how are we thinking about the world? We have data sets that collect data from order books, from blockchain records, from derivative, from social networks, use representation learning to generate massive catalogs of features on that, and use AutoML to test large amounts of models on top of it. Then the top models, we refine them, we go through the normal handcrafted manual process, and that derives into training strategies. But our path to experimentation has shrunk a lot. So this is very, very cutting edge. So these are some articles of the last year. So this is what Waymo is using for testing models in self-driving car. Google Research just published some research about AutoML for time series forecasting literally in December 2020. Uber is working on this, and they open source a stack called Ludwig. That is what they use for AutoML internally. So this is very, very cutting edge, but also very, very promising. Then the second challenge that we have is how do we evaluate some new research ideas that could be applied to forecasting problems in the crypto space. We think these are very hard problems. We don't think that you take a vanilla model and generate alpha very easily. And so we think that the alpha discovery is going to happen with very sophisticated models that take a lot of work to put together. So therefore, it's important that you pay attention what's coming out of the top research labs in the world. And then in the last couple of years, we have had major milestones in machine learning. So everybody knows about GPT-3. Obviously, generating text or answering questions in a way that is almost indistinguishable from humans. If even the most optimistic people in the natural language understanding space, if you told them this was going to happen 5 years ago, they would have laughed. I mean, it was the architecture underneath GPT-3 that is called transformers is probably the biggest milestone in machine learning in the last 10 years. Then even as important, just a few days ago, DeepMind cracked what is called the Olympics of protein folding, one of the hardest problems in the world of biology. That is, how do you determine the structure of protein based on a sequence of amino acids? So it's a massive problem that never been solved, and they produced this model called AlphaFold that was able to crack that challenge. And the models behind AlphaFold is something that could be applied into all sorts of domains. This just happened a few days ago. So those techniques, the architectures underneath those models are making the news, are being adapted to time series. So here are some snapshots from Google Research, from Amazon Research, from Facebook, their AI research group. So all this stuff is actually happening, and we're seeing a ton of adapting those modern architectures to the world of time series forecasting. Then every year there is this type of competition called the M5 competition, in which researchers take their more advanced time series ideas and compete against a series of problems. So we're paying a lot of attention what is producer and trying to adopt it. From all that world, one idea that we like a lot is this thing called temporal fusion transformers. That is, think about GPT-3 for time series, right? The same thing that allowed GPT-3 to answer questions or generate text in a way that is indistinguishable for human. There has been adaptations of that architecture to time series models, because as an architecture, transformers were a big milestone in the deep learning space. Many people believe that it's leaving behind some massive trends like recurrent neural networks and LSTMs and things like that. So the way it works, the way you apply it to time series, and particularly in cryptos, think about, you have all this data set. And there is a layer called an encoder that will look at all those data sets and will generate features on the fly. And there is another layer that will take those features and make predictions, but it's using this mechanism called attentions, that is like a memory mechanism that is going back on time and at any point noting what are the important things about that sequence. So let's say we're analyzing Bitcoin order books in a 5-minute span and there was a spike, and it would note that, okay, this was relevant, right? So it will capture that, and then it will use that knowledge to forecast in the future. So the whole revolution of transformer was started by a paper from Google called Attention is All You Need, in which described that layer of attention that you could build in neural networks, and that's what makes transformers so unique. Again, very new, but Google itself produced this thing called temporal fusion transformers, in which they took that architecture that is powering GPT-3, that is powering other models in natural language runtime, and adapted for time series. And this is something that we think is super, super powerful. At the same token, here are some technologies, just to keep it very practical, that we have been trying and are excited about. Obviously, we're using AutoML, so Automotive Stacks. So this fast track your experimentation time. Azure AutoML, AWS Autopilot, AWS Research published this thing called AutoGluon that is super, super interesting. Then interpretability stacks, so things that allow you to look at a neural network and try to understand what it's doing. A stack that we like a lot there is called Fiddler AI. Feature stores. If we have 300,000 features to make predictions, how do you store that? There is a type of technology called feature stores that is very new, but it's sort of becoming a market within AI. There are companies there like Tecton that are the guys who build this at Uber. AWS got in the game a few weeks ago. They launched a feature store in AWS. There is HubSpot, there's Fizz, there are other technologies there that we're testing. We're testing a couple of those, and these are stacks that are becoming technologies that are becoming sort of building blocks of our stack. Finally, I want to make a quick note about how we see decentralized finance in that world, because we're also building quant strategies for DeFi models. So in our view, DeFi sort of is a brand new playground for high frequency trading. So a lot of what was happening in 2007, 2008 in high frequency trading in dark pools is now happening in DeFi. Like a lot of those algorithms are applicable to the DeFi space. So we think it's a transparent playground in which everybody sees what everybody else is doing, and it's let the best algorithm and the best infrastructure win type of approach. So we believe that also DeFi, in that world, there is a lot of value for having predictive models and intelligence signals. But we also believe that in the future, and I explained that thesis before, intelligence is going to not only become something that is a signal to a DeFi protocol, but a component of a DeFi protocol. So you're going to see things like intelligent AMMs, in which instead of doing a 50-50 split like a Uniswap, they get a signal from the market, or they use a predictive model, or they use something more intelligent. Obviously, you're going to use protocols that can generate alpha by themselves. Like you can take one of our predictive models and build it into a protocol. You're going to have intelligent robo-advisors and make intelligence a layer of the DeFi stack. So summarizing all this. So the future of crypto asset predictions is going to be deep learning. I mean, there is no other way. Representation learning and AutoML, from all the new cutting edge stuff that is happening in the deep learning space, these two are practical and are delivering value. Time series forecasting research is accelerating very, very rapidly. So keeping an eye on what's happening out there. I mean, if you're trying to discover alpha in the space, it's probably a good idea. And DeFi is certainly a new area that is worth paying attention to. So that's what I wanted to cover. Again, 30 minutes. We tried to keep this very short. I'm going to go to questions, but before that, there are a lot of questions. I would like to announce our next webinar. I told you we're doing a large release on capital markets. So my colleague, Lucas Otomoro, is going to do a session about giving you all sorts of cool analytics that compare crypto against traditional capital market vehicles. So we're gonna start talking about things. Well, how are IPOs doing versus crypto? How is Tesla? ETF that are interesting to look at, different theses and things like that. So it should be super, super cool. It's gonna be on February 3rd, 2021. The link is on the chat, or it's going to be. So go register and also sign up for Into the Blog so you have access to this release. Let me go to questions. There are a million questions here. So let me start going through some of this. My God. So Austin say, thank you for the knowledge. Thank you, Austin. Yes, the session will be recorded and posted in our YouTube channels. Ufuk caller is asking, would you consider to fork the training of the model and proceed with multiple models? Do you learn from the delta? Yeah, absolutely. So I'm not sure if forking is probably not the term, but what you can take many with feature extraction, many data sets and calculate, different quantiles and things like that in time series. That is what that is a very typical technique. Then Guyen Shao is asking, or Kao, what does a stochastic volatility models fall into? So volatility is typically one of the features that you use as part of this predictive models, and it's also used very often as a sign of risk, right? As to evaluate risk with predictive models. Bran is asking, how long do you use a model? Do you retrain a model? This is a big challenge. So this is a very interesting question. The answer is it depends on the model, but there are three criteria that we tend to use. One is there is a model decay, the performance degrades, so you need to retrain. Also, there is a market event. Even if the performance is good, there is a market event that you want to capture, and three is time. Right? You haven't trained them all in a month. Now that's not discrete, right? It's a very it's even not very empirical either. There is an art to that because there are challenges that what I mentioned. Sure, there is a market event, but if you train them all, you're overfitting. So what do you do? And if you don't train them all, you might get killed. So there are challenges like that that are super difficult to solve, but that's sort of the criteria that we're trying to use. Christy is answering, are you providing an API to access all these indicators provided by ITV? Yes, ITV has an API that is offered to customers. It's a license-only API. It has over 120 indicators. It has some predictive models. It doesn't have other predictive models that we're using with QuantDesk and things like that. We only use those in alpha generating strategies. But you can get a lot with the ITV API. Shoka is saying, great job, thank you very much. Ruben is saying, thank you, this is amazing. What do you think about Numerai? Ouch. I do have some very strong opinions about that, which I probably should not disclose. I think the approach of crowdsourcing strategies is theoretically, there is a lot of value. People see a lot of value. Practically speaking, I think it's controversial. Like there is a lot. So there is obviously a value of having a ton of data scientists produce models that, compared to what 3 people on your team and all that can do. The challenge has been that having those models be actionable and maintain over time has proven to be difficult. And this is not, I don't really know how Numerai is doing, if well or bad, but this has been a traditional challenge of every fund that took that approach. Quantopian very famously raised 200 million from Stevie Coin, SSC Capital, and SAC Capital and 0.72, and couldn't deliver any performance and had to shut down the fund. So with the same approach, so that it hasn't really worked in that area. Some funds like World Quant and all that, they have been very successful at it, but it's very very surgical, very tailored. They go to 5 groups instead of 500, right? And something that they can manage. So it is controversial, and that's probably what I can say publicly. Then is there a future for XRP? Jensen is asking. I don't know. It seems like complicated right now, but it's a lot gonna ride on the output, on the outcome of that of the case with the SEC. Then Bran is also asking future pricing with regression models, buy wholesale momentum with a classification model. So this, yes, so another good question from him. That's a classic technique in time series forecasting. In markets is difficult to apply, particularly in crypto, because it's very vulnerable to market fluctuations. Even if you use models like Prophet that are very optimized for seasonality and things like that, it still hasn't proven to be very resilient. Dan is asking, are you able to share any preliminary results of crypto asset prediction? Yeah, of course. The simplest one, you can find it into a blog. If you want to talk about the performance of the ones that we're using for trading, send me a note and we're gonna schedule a call and we can discuss those in detail. And then on the other side here, Inigo is asking representation learning. Once you figure out the variables within a data set that have sufficient predictive power, do you weight them according to power effectiveness? Not that simple. Yes, but it's not it's an algorithm that does that, among other things. And it's not like linear weights and all that. Think that it could be 100,000 features making a prediction, and some features could be related to others and things like that. So there are layers and layers. So it's hierarchical, not linear. So the answer is yes, but it's a little bit trickier than that. I think I cover pretty much everything. So thank you very much for joining. I think this webinar was a record attendance. I hope the content was, I didn't bore you with too many technical details. I hope it was helpful. And I hope to see you in 3 weeks in the next webinar. Go sign up. Lucas is going to show you a ton of cool stuff. And please sign up for Into the Blog and give us a ton of feedback. Thank you very much. See you in the next one.